Okay, hi everybody. Hopefully you can hear this okay. I am going to just go through a few slides. I know I posted these a few days ago without the voice. I am now able to talk to you through it a little bit. I don't expect that you've actually, understood everything, or if you've read the textbook, it's a little bit different than what we're used to. So I do feel it's important to just kind of talk this through. And then on Tuesday, we will get more into depth about what this means. It'll be much easier with me in front of you, and then we can do some practice problems, which I definitely believe you will need, and you will need some instruction and assistance with. So let's go ahead and get started. So we're looking at, I'm just going to actually go back to from the start. Okay, so we're looking at two-factor independent measures ANOVA. So before we were looking at one-factor independent measures, right? So we were looking at how one factor or one independent variable would have an effect on a dependent variable. So it's really similar to the t-test that we did before, specifically the independent t-test. So instead of now having one factor, so we had, if you remember, we had, an age example. So we had 10 years old, I think it's 6 years old, 8-year-old kids, and 10-year-old kids. And we had those three groups, and then we had questions about, well, does age actually have an effect on their reading proficiency, for example? And so, we could ask that type of question. But with a two-factor independent measures ANOVA, we have two factors. So it's kind of like, well, look at how age might have an effect on the difference among all of those scores on, say, reading tests. But then there's other questions that come up, right? I mean, there's kind of questions like, well, are these males or females, or are they kids in different types of socioeconomic status areas? Are these kids who have previously done well in reading and not now? Are these kids who are second language as readers? Okay, so there's a lot of different variables in there, right? So we can always, if we're interested in another question, we can always ask another question. So we can see if, okay, let's look at not only age, but within age, how maybe we might be interested in socioeconomic status. Okay, so we might be interested if they're coming from a low end school, or more of a wealthy area of town. So anyway, say we want to do that, then we're going to have to run a two-factor independent measures ANOVA. Okay, so so next slide. So to measure, to observe how one variable interacts with another, it's necessary to study both variables simultaneously in one study. So really we're looking at not only the mean differences between the variables, but we're also looking at how the two variables work together and interact together in order to lead us to the outcome. Okay. So, like I said, the one-factor ANOVA was limiting in evaluating mean differences because there was only one independent variable. So it was sort of fixed as to how much variability we could get just from one factor. So this is actually kind of opens it up and allows more sophistication in our design, and therefore it allows us to ask more and better questions. Okay, so for example, in a one-way ANOVA, we might find that a weight loss drug has a significant effect on weight loss, but there's probably some other factors that could have an influence on weight loss, like the amount of exercise, for example. So in a two-factor ANOVA, we can determine if weight loss also depends on level of exercise. And this is an example that we've actually used in class before, kind of like, well, there seems to be a lot of variables that might have an influence on loss of weight besides just a particular weight loss drug. Okay, so this two-factor ANOVA will help us to look at those variables and see if there really is an interaction, if there really is something else that's influencing weight loss, that's not the original independent variable or factor. Okay, so you have actually in class, I don't know if you have your textbook in front of you um, or on your screen, but there's a great example in the textbook, and I wanted just to use that. And the textbook is discussing a study that's been done, and it asks the research question, does experiencing violence in video games have an effect on the player's behavior? So it's a good question, but of course there's maybe some follow-up questions involved there too. So we're going to study what that looks like, and kind of, the textbook helps, but we're going to look at how it's set up conceptually, and then we're going to look at well, we might, if we have time, we're going to look at another one that's set up and how it's set up conceptually. And then either on Tuesday or the next day on Thursday, we will start running the hypothesis tests. And if you've looked at the textbook, you've seen that these tests are a little bit more involved. Okay, so we can say that the Two-Way Anova compares the mean differences between groups, I'm sorry, that have been split on two independent variables. Okay, research studies with two factors are called factorial designs, or simply two-factor designs. So we can refer to Two-Way Anova as that, but it's more common to call them now two-factor designs, okay? Because are we really going a certain way? Two-factor is a little bit more specific and more relevant to what we're really doing in this process. Okay, so the primary purpose of a Two-Way Anova is to understand if there really is an interaction between the two independent variables on the dependent variable. Okay, so the word interaction is going to be really important when we're looking at two-way, or I should say two-factor designs, two-factor ANOVAs. And so we're going to look at the aggression study, and I have a worksheet for you that just kind of spells it out in case you haven't read the textbook or you have forgotten what the study was about. So we have some research questions that come from that. And it's cool because the research questions, I'll read those in a second. But so what's great about the two-factor ANOVA, it allows us to examine three types of mean differences in one analysis. So you might be asking yourself, well, what's the difference between a one-factor analysis, a variance, or independent t-test, or doing three independent t-tests? Well, the answer is simply we have kind of like rolled into three mean difference or treatment effect hypotheses into one. So once again, kind of like the one-way or one-factor ANOVA, we're accounting for lots of error. So when we roll in all of these hypotheses tests, we're also going to get an F ratio for these hypotheses tests, and therefore they're all going to we're going to limit the amount of type 1 error that we could commit, or the potential or probability of type 1 error that we could commit, just like when we did the one-factor ANOVA versus the independent T. Okay, all right. Okay, so we can ask the questions in this study. I think that it's important to look at the actual questions and kind of how they're spelled out. So we have looking at these following mean differences. One, we're looking at low violence games versus high violence games. There's two variables. Two, we're looking at males and females. There's two variables. And three, we're looking at the violence level times the gender interaction. So when we write violence times, okay, and that's just that X, right? So we're gonna write violence, oops, sorry, um, and gender interaction. That's just what that means, okay? So we're actually going to get, believe it or not, F ratio for each of these, okay? And then we're gonna end up with an overall F ratio of the outcome variable or the results that we hope to find. Okay. Okay, I'm sorry for the pause here. Actually, okay, so we are examining 3 types of mean differences and putting them all into one analysis. Okay, so if we look at our at the example, and like I said, you might have your book in front of you or on the screen. I am going to print out an example of that for you, and you'll be able to just have like a separate sheet of paper to look at and to read about the study. So, you know, the questions. Let me read them to you again, just to make sure that we're on the same page. So we're looking at a study that the researcher would be interested in seeing how playing violent video games or non-violent video games, if that actually has an effect on aggressive behavior. And then if it does, then is there more male, is it more affected by male or females, okay? So the questions would be, what happens to the level of aggressive behaviors when violence is added or taken away from the game? I'll go ahead and put these up here. Is there a difference in the aggressive behavior for male participants compared to females? And then the third, the interaction question. Is aggressive behavior affected by specific combinations of game violence and gender? So for example, a violent game may have a large effect on males, but only a small effect on females. So there's kind of another variable process working there as well. Okay. So this is sort of redundant, I know, but I really am. I think it's going to be really important to understand these concepts and why we do run a two-factor. So the two-factor ANOVA, again, allows us to examine 3 types of mean differences within an analysis. We will be conducting 3 separate hypothesis tests for the same data. So here's hypothesis test, here's a hypothesis test, and here's a hypothesis test. Okay, so for the 3 different questions, okay? And then the 3 F ratios have the same structure, so that's pretty easy. So we have the variance or the differences between treatments divided by the variance or differences expected if there is no treatment effect. So really there's not much difference between what we've looked at with the original one-factor ANOVA, and so we keep that in mind, right? We keep this in mind that this test statistic is still an F. It's still an F ratio. The F ratio is still going to involve variance between, variance within. Okay, we know that between is the treatment effect if there is one, and then the variance within is exactly what this is. If the amount of error expected if there is no treatment effect, okay? So we have those 3 ratios, 3 F ratios that we're going to calculate. All right, I actually want to move back here because what we do is we put our, when we draw this out, okay, it's easier to just make a matrix, okay, instead of making like a narrative of what's happening. So We usually make a matrix because we have more than one factor, more than one independent variable. And so the matrix looks a little bit like this, and you guys will be making these yourselves. So we have factor A, okay? So in this case, factor A is gender. So usually when we do two factor analysis ANOVAs, we have two factors. We call them factor A and factor B. And so once again, you're going to hear this a lot, but the goal of a study is to evaluate the mean differences that may be produced by either of these factors acting independently or by the two factors acting together. So nonviolent versus violent, male versus female, or is there just kind of an interaction here that can both account for whatever the outcome is on aggressive behavior. Okay, so this is what we looked at. Okay, so another really important term to remember besides interaction is something called main effects. Okay, and so when we look at main effects, a main effect is really just the looking at the mean differences. Okay, so one purpose for this study is to determine whether differences in gender, which would be factor A, result in differences in behavior. Okay, so we're looking at the differences in males and females, and does that result in any difference or any effect in behavior? Okay, so then okay, sorry. So then the second level, okay, I'm sorry. So we have males versus females. All right. So if you look at the males being, in the green and the females in the blue, we have a sort of our hypothetical data, right? So we have males having a score of 7 on the aggression test, and females having a score of 3 on the aggression test. And so we have an overall mean of 5, which we've done before, but clearly you can see that there is a difference, okay? We don't know the difference until we conduct this hypothesis test. Similarly, when we look at the non-violent games versus the violent games, okay, we can see that there is the violent game is looking at an M of 7, okay, for the males. And an M of 8 for violent games. So we're now looking across, right? And we're finding that there's an overall mean of 8 when you compare violent games versus non-violent games. And then you can also look at the females and see that nonviolent games played by females, there's an M of 3, of course, and when the violent games played by females, an M of 5, which an average of 4. Okay, now it's interesting because we put this in a matrix, and we can see by just looking at the the rows or the columns. Okay, and that's kind of an important thing. Sorry. So now we have the means, okay? So we're going to evaluate the mean difference between the top row and the bottom row, okay? So that's one thing. And then here we're going to evaluate the the mean difference between the left column and the right column, so nonviolent games and violent games. So this is our B, this is our factor B. So we're going to also determine whether differences in levels of violence result in differences in behavior or have an effect on behavior, which was our original question. So we compare the mean score for the nonviolent games with the mean for the violent games. And like I said before, we have we have an M. We have a mean of 5 and a mean of 7. Okay, so the process evaluates the mean difference between the left column and the right column. Oops. So the left column and the right column, okay? Okay, So here's a little bit more about the mean differences, main effects. So the mean differences among the levels of one factor are referred to as the main effect of that factor. So if you look at this, when the design of the research study is represented as a matrix, which it usually is, with one factor determining the rows and the second factor determining the columns, then the mean differences among the rows describe the main effect of one factor, and the mean differences among the columns, okay, there's the rows, the mean differences among the columns describe the main effect for the second factor. Okay, so you have males versus females, and we have nonviolent games versus violent games, and those can be divided up, but you don't necessarily have to draw arrows and divide them up. I think that we'll be able to look at that and know, which variables we're considering, and then of course you can always somehow mark the ones that you, just in case you're a little confused between factor A and factor B. Okay, so factor A, males and females. Factor B is violent games versus non-violent games. So that is the sort of overall use of main effects and of the aggression study, looking at males and females. We will talk more about this on when we meet again on Tuesday, and we're gonna then move on to looking at a whole other example of a two-factor independent measures ANOVA, and then we will go ahead and I'll show you how to walk you through a hypothesis test. So let's go back here. So we didn't get a chance yet to look at interactions, and we didn't get a chance yet to run this hypothesis test. So what's going to happen is, instead of running this hypothesis test, you can look in your textbook and you can kind of read through that, and that's a really good example. The actual question, the answer is that when you're, the question was, do violent games, video games, have an effect on aggression, and then if it does, does that affect males or females more? So the answer was that violent video games do have an effect on aggressive behavior, but not so much with females as in males. So there was a significant difference and a significant interaction between these two variables. So obviously the violent video games were not the only variables that were influencing the outcome variable. That the gender variable A, was also affecting that as well. So we have all our answers or questions answered, but we can also see that there is sort of a intervening variable, and that would clearly be gender. Okay, so we'll talk more about the interactions on Tuesday, because we need to kind of look at all of that as all together before we go into our hypothesis testing. So we'll look at the main effects again for a couple different studies. We'll then look at our interactions, and then we'll get into the hypothesis testing and the math for that. Okay, so hopefully this is sort of helpful, and I know that being there in person is going to be much easier. So we will go over, if you have any questions, we'll talk about these on Tuesday. I'm happy to go through some of the conceptual stuff on main effects. But we do have to move on, right? Because the end of school is coming soon, and we have to get through a couple more chapters. So there's nothing really due on Tuesday. I will just see you then, and we will continue this process. Okay, thanks a lot. Have a good day.